Welcome to the lecture series on time value of money, concepts and calculations. In this lecture, I will teach valuation of bonds part 1 and valuation of bond part 2. Bond, a debt instrument issued for a period more than a year with the purpose of raising capital by borrowing. The government agencies and business enterprises sell bonds. Generally, a bond is a promise to repay the principal on maturity along with interest. Now, let us see something which is related to the bond. Par value, it is the face value of the bond. Coupon rate is the specified interest rate. Interest payable to bondholder per year is equal to par value into coupon rate. Maturity period, it refers to the number of years after which the par value is payable to the bondholder. Let us take an example, example 1. A firm has issued a 10-year bond with 1000 par value with 10% coupon interest rate with interest paid semi-annually. The bondholder has a right to get rupees 100 annual interest, which comes out from par value into coupon rate, which is 0.1 into 1000 is equal to 100, paid as rupees 50, 100 divided by 2 at the end of every 6 months and rupees 1000 par value at the end of 10th year. Let us take an example, this is called example 2. A firm has issued a 10-year bond with 1000 par value with 10% coupon rate as well as discount rate. That means, discount rate and coupon rates are 10%. With interest paid annually, compute the value of the bond. Now, if we analyze this bond is giving 100 rupees at the end of each year up to 10 years. So, this is shown here in the timeline. At the end of the first year you get 100 rupees, end of the second year you get again another 100 rupees, so on so forth up to the end of 10th year you get 100 rupees. The present values of these 100 rupees can be calculated using this formula, which is being used to calculate the present value of annuity. This is P equal to A in brackets 1 plus I to the power n minus 1 divided by I 1 plus I to the power n. And then this timeline shows at the end of 10th year you will get 1000 rupees, and the present value of this 1000 rupees can be calculated by bringing this value to timeline t equal to 0. So, here the present value is calculated in two groups. This first group shows the present value of the annuity and the second group is related to this figure, that is at the end of 10th year you will get 1000. So, when you put the values, this becomes 100 into 6.14456 plus 1000 into 0.38554, which comes out to be rupees 999.996, which is almost equal to 1000. Here the 100 rupees interest paid annually for 10 years is considered as annuity for 10 years, and discount rate is 10 by 100 is 0.1. Conclusion: the bond value is equal to the par value. When coupon rate is equal to discount rate, then bond value is equal to par value. Now, values of bond with different coupon and discount rate. The values of the bond is the present value of the contractual payment its issuer, that is government or business enterprises, obliged to make from the beginning till maturity. Now, to find out what will happen if the bond has got different coupon and discount rate, we have taken the example 3, the value of a bond. Bond of SS International matures in 5 years with a coupon rate of 7% and a maturity value of 1000. For simplicity, let us assume that the bond pays annually and the discount rate is 5%. Here we see that the coupon rate is 7% and discount rate is 5% and hence discount rate is different than coupon rate. In earlier questions, the coupon rate was equal to the discount rate. As the cash flow for each of the year is as follows. After just 1 year, this 70 rupees will get as the interest, that is par value 1000 into coupon rate divided by 100, coupon rate is 7%. So, this is 0.07 into 1000 is 70 rupees. So, after just 2 years 70 rupees, after the 3 years 70 rupees, after the 4 years 70 rupees, and after the 5 year this is 70 plus 1000. So, it becomes 1070. This is par value plus interest. Now, thus the PV, the present value of the cash flow is as follows. Present value for after just 1 year is rupees 70 divided by 1 plus discount rate divided by 100 to the power 1 is 70 divided by 1 plus 5 divided by 100, this becomes 66.66 rupees. Similarly, the present value after just 2 years is 70 divided by 1 plus 0.05 square, which comes out to be 63.49. Similarly, PV after just third year is 60.47, PV just after fourth year is 57.59, PV after 5 years is this is 838.37. Here we will see that for discounting we are using the discount rate, while finding out the interest we are using the coupon rate. Now, to find out the value of the bond, all these present values are added up. So, the bond value is 1086.59. The value of the bond when discount rate is same as the coupon rate was 1000, but in this case it is different. We will illustrate the valuation bond with reference to basic bond valuation, yield to maturity and semi-annual interest and bond values. Now, let us take an example, example 4. The bond of SJ International matures in 5 years with a coupon rate of 7% and a maturity value of 1000. For simplicity, let us assume that the bond pays annually and the discount rate is 5%. Now, here we are using formula to get this values. So, every end of the every year we will be getting rupees 70, rupees 70, rupees 70, rupees 70 and rupees 70 up to 5th year, and at the end of 5th year rupees 1000. So, interest per year is 1000 into coupon rate divided by 100 is equal to 70 rupees. If interest per year is considered annually a annuity, then the present value of the series of annuities can be calculated as PB of the annuities is equal to annuity into this formula, which I had already told you in the last question, and if you put this comes out to be rupees 303.0634 when n is the maturity period 5 years and the I is discount rate is 5%. At the end of the maturity period, the bearer of the bond gets 1000 rupees. So, if we want to find out what is the present value of this 1000 rupees, this is equal to 1000 divided by 1 plus I to the power n, where n is 5, this comes out to be rupees 783.526. The present value of bond is therefore this value 303.0634 plus this value 783.526 come out to be 1086.59. Now, we see the results are the same, whether I can go from the first principle to find out the present value or I use the formula. Effect of discount rate on bonds value. So, what we saw here that we will find out the same problem will be solved for two different discount rates 5% and 10%, and then we will find out the conclusion, what is the effect of discount rate on bonds value. For this we have taken example 5, the value of a bond with different discount rates. Bond of SJ International matures in 5 years with a coupon rate of 7% and a maturity value of rupees 1000. For simplicity, let us assume that the bond pays annually, compute the value of the bond for two different discount rates 5% and 10%. Now, this 5% values and 10% value has been taken with a purpose. 5% is less than 7% and 10% is more than 7%. So, the value of the bond when discount rate is 5% is 1086.59 and the value of the bond when the discount rate is 10% is 886.52 and the value of the bond when the coupon discount rate is 7% is 1000. So, what we saw that when the discount rate is 5% the value is more than 1000 and when the discount rate is 10% is more than 7% the value is less than 1000. So, let us see here the present value of the cash flow when discount rate is 10%. So, this can be calculated from the first principle, this 60 the end of the first year interest, 70 is when its present value is calculated by dividing it with 1.10 to the power 1. Here I am taking the interest discount rate to be 10%, this is 63.63. So, similarly these values can be converted to their present value. So, it comes out to be rupees 886.52 and this is for discount rate 10%. Now, what conclusion we make? When discount rate is different than coupon rate, the value of the bond will differ from its par value. This is number 1 conclusion. The number conclusion 2, when discount rate will be more than the coupon rate, the value of the bond will be less than the par value. Now, my par value was 1000 and will sell at a discount. I know that when the coupon rate was more, that is 10%, the value of the bond was 886.52, which was less than 1000. So, it will sell at a discount and discount will be rupees 1000 minus rupees 886.52, which comes out to be rupees 113.48. When discount rate will be less than the coupon rate, the value of the bond will be more than the par value and will sell at a premium, and this premium is equal to 1086.59 minus 1000, which is the par value, is rupees 86.59. So, when my discount rate was 5%, the bond will sell with a premium of 86.59. Now, let us take an example. In this example, we have calculated the value of the bond with different discount rates 5, 7, 10%, 12%, 14% and 16%. So, here we see when it is 5%, the value of the bond is 1086.59, when it is 7%, it is 1000, when it is 10%, it is 886.2764, when it is 12%, it is 819.7612, when it is 14%, it is 759.68 and when it is 16%, it is 705.3136. So, when the discount rate is 7%, which is equal to coupon rate, the value of the bond is equal to the par value, and if the discount rates are more than 7%, the bond rate decreases. So, in this figure it shows this is the value of the bond, that is par value of the bond when discount rate is 7%, and when discount rate is less than 7%, the value of the bond increases, but when the discount rate is more than the coupon rate, the value of the bond decreases. So, this is discounting and this is premium. The green is premium, red is discounting. To show the effect of maturity period on bond value, we have taken example 7. The value of a bond computed for different maturity period when discount rates vary. Mr. SJ International has floated bond with a coupon rate of 7% and a maturity value of 1000. For simplicity, let us assume that the bond pays annually. Compute the value of the bond for 3 different discount rates 5%, 7% and 10%, and maturity period starting from 0 year to 10 years, and this has been the results has been tabulated in this table. Now, if see the maturity period is 0, then bond value is 1000 for 5% discount rate, 1000 for 7% discount rate and 1000 for 10% discount rate. That means that irrespective of the discount rate, if the maturing period is 0, the bond value remains 1000. Now, if it is 1 year, I find that the bond value for 5% discount rate is 1019.048 and for 7% it is 1000 and for 10% it is 972.7273. That means, bonds value will be more than 1000, that is par value, for even when the period maturity period is 1 year, and the bond value will be less than 1000 when the discount rate is more than the coupon rate. Now, here we see that when the bond discount rate is 7%, which is equal to coupon rate, for all time to come, that is all maturity periods, the bond value remains same, that is 1000. However, when the discount rate is 5%, the bond value increases with maturity period. For 1 year it was 1019.048 and for 10 years it is 1154.835. That means, the value is increasing with maturity period. Let us see the scenario for 10% discount rate. Here the value is decreasing. In the maturity period 1 year it was 972.7273 and for 10th year this is 815.663. So, the value is decreasing when I am increasing the maturity period. So, I get a plot like this. This will be a discounted bond, this is the par value. So, this will be obviously a discounted bond and this is a premium bond when the discount rate is 5%. Now, they change like this. So, when the discount rate is different than coupon rate, the time to maturity would affect the value of the bond, even if the discount rate remains constant till maturity. And what is the conclusion? The shorter is the time to maturity, the smaller is the impact on bond value caused by a given difference between the coupon and the discount rate. Now, the other method for finding out to evaluate the bond is yield to maturity, which is called YTM. Yield to maturity, YTM, is the rate of return that an investor earns if he buys the bond at a specific price and hold it until maturity. It is presumed that the issuer of the bond makes all the interest payments and payment of the principal as contracted. YTM is a bond whose current price equals to the par value, that is purchase price is equal to the maturity value, will be always equal to its coupon rate. In case the bond value differs from the par value, YTM value will be different than the coupon rate. To show this, how to calculate YTM, let us take an example, which is example number 8 to compute YTM. SJ International is currently selling a bond for rupees 1900 with a coupon rate of 10% and a maturity value of 10,000. The maturity period is 10 years. The bond pays interest annually. Compute YTM. Now, let us see the solution of the problem. Now, for the present problem, n is equal to 10 years, interest paid per year is 10,000 into coupon rate by 100 is equal to 1000, and at the end of 10 years the firm pays 10,000 as maturity value. Now, if you see this, the interest, that is 1000. So, interest is paid for 10 years. So, interest is an annuity and the present value of this annuity is this, where this A is the annuity 1000 rupees and this formula was used to find out the P, this is present value. And the end of 10 years one gets 10,000 and the present value of this 10,000 is 10,000 divided by 1 plus I to the power n. So, when we add the present values of these two, then this is equal to 10,900. So, the problem is that what should be the value of I which will give us this value, and that value of I is required. Thus, one has to compute the value of I discount rate which will make the present value of the above investment as 10,900. As the maturity value is more than 10,000, I should be less than the coupon value. The value of I for the present problem will be the YTM. Now, let us see the computation. As a first estimate, let us consider discount rate, in this case YTM, as 9%. The present value of the series of above investment for 9% discount rate is rupees 10,641.77, which is less than 10,900. Hence, a lower value of discount rate has to be considered, and let us take it as 8%. The present value of the series of above investment for 8% discount rate is rupees 11,342.02, which is more than 10,900. Hence, the actual value of the discount rate should be in between 8% and 9%. The approximate value of discount rate, which will offer present value of 10,900, can now be computed using interpolation or by trial and error. The difference between the bond value for 8% and 9% discount value is rupees 11,342.02 minus rupees 10,641.77, which comes out to be rupees 700.25. That is, for 1% difference in discount rate, that is a difference of rupees 700.25 in the present value of the bond. Difference between desired value and the bond value for lower discount rate 8% is 442, which comes out as rupees 11,342.02 minus rupees 10,900. So, actual discount rate will be 8 plus 442.02 divided by 700.25 is equal to 8.631232. Now, for the discount rate of 8.631232%, the present value of the bond is 10,892.87, which is almost equal to 10,900. But the actual value of the discount rate by trial and error is about 8.621, for which the present value of bond is 10,899.95. So, the YTM rate is 8.621, which is less than the coupon rate of 10%. Now, let us see a third type of evaluation, that is semi-annual interest and bond value. The procedure to value bonds paying interest semi-annually, that is half yearly, is similar in computation to the situation where compound interest rate is charged more frequently than annually. Following steps are involved in the computation. Convert annual discount rate to semi-annual discount rate by dividing it by 2. Convert the maturity period given in years n to number of semi-annual period by multiplying it with 2. Convert the required interest paid annually to semi-annually by dividing it by 2. So, let us see an example to demonstrate this. Example 9. Compute the value of the bond when interest is paid semi-annually. Messrs. SJ International has floated a bond with a coupon rate of 7% and a maturity value of 1000. For simplicity, let us assume that the bond pays semi-annually. For two required discount rates 10% and 5% and maturity period is 5 years. Compare the value of the bond under similar condition when the interest rate is paid annually. So, there are two discount rates 10% and 5%. So, let us see the solution. The value of the bond when interest is paid annually. Now, we will start the calculation with discount rate of 10%. So, my first calculation is with discount rate of 10%, where n is the maturity period equal to 5 years, I is the discount rate 10%, which is equal to 10 divided by 100 is equal to 0.1. Present value of the bond is 70. This is the interest per year, and this interest per year is taken as annuity and is converted into the present value, and this 1000 which we are getting after 5 years is also converted into the present value. So, when we add the two present values, it comes out to be 886.27634. Now, the same problem will evaluate with semi-annual interest rate, and we will see what is the value of the bond for semi-annual interest rate. The value of the bond when interest is paid semi-annually with discount rate of 10%. Now, here the value of the interest, the bond value into coupon rate is 1000 into 0.07 is 70 rupees, and this 70 rupees is paid semi-annually, and thus it is equal to 35 because 70 divided by 2. So, it will be spread over 6 months, that is why it is rupees 35 paid every 6 months up to the end of 5 years. This means that in 5 years 10 payments each 35 will be paid every 6 months. Thus, annually it can be taken as 35 for 10 consecutive payments when gap between the two payments are 6 months. Please note that the present value of a annually formula has been changed to accommodate compounding semi-annually. In this case, when compounding is semi-annually, compounding every 6 months and twice annually, and hence m is equal to 2. For this problem n is equal to 5 years and I equal to r equal to 10 divided by 100 is equal to 0.1. So, for compounding semi-annually this formula is used, which is a discrete compounding formula, and this is the p, that is present value, and this is the a, which is the annuity value. The present value of the annuity is equal to annuity, that is 3500 into this group, which comes out to be, when we place the values, it comes out to be rupees 270.261. Now, again the PV, the present value of the 1000 paid at the end of 5 years when compounding is semi-annually, is this 1000 divided by, in brackets, 1 plus I by m to the power mn, which comes out to be rupees 613.9133. So, thus the present value of the bond is this 270.261 plus this one, which is 613.9133, it comes out to be 884.1743. The value of the bond when interest rate is paid annually with discount at 5%. So, we have calculated for 10% discount rate, now we will calculate for 5% discount rate, and here we are, the present value of the bond is 70 into this formula, which is a annuity formula when compounding is annually, and this is 1000 is transported to present value by dividing it with 1 plus I to the power n. So, this is annually. So, it comes out to be rupees 1086.5896. So, when discount rate is 5% and the compounding is annually, the value of the bond is 1086.5896. The value of the bond when interest is paid semi-annually with discount rate 5% and compounding semi-annually. So, the semi-annually compounding formula is used, and this comes out to be 1087.521. So, what are the conclusion we draw out of this? The conclusion is the value of a bond selling at discount is lower when semi-annual compounding is used in comparison to annual compounding. And number 2 conclusion is, for bonds selling at premium, the present value with semi-annual compounding is greater than the annual compounding. And we already know that what is a discounting bond and what is a premium bond. In the discounting bond, the discount rate is more than the coupon rate, and in a premium bond the discount rate is less than the coupon rate. Now, let us take another example, example number 10. SJ International is selling bond of 1 lakh dated January 1, 2016 for coupon rate of 9% and having interest payment dates of 30th June and 31st December each year for consecutively 5 years, and will have following semi-annual interest payments and one time principal payment of rupees 1 lakh at the end of the maturity period, and discount rate is 8%. This timeline very clearly shows this numerical. So, here at the first period, which is 6 months away from the t equal to 0 timeline, that is on 36/16, 4500 will be paid, and then after 6 months again 4500 will be paid, and this will move till the 10th period comes, where 4500 plus 1 lakh will be paid. Let us see the solution. As indicated in the timeline diagram above, the bond issuing from Messrs SJ International will pay to its bondholder 10 identical interest payments of rupees 4500, from where it has come, rupees 1 lakh into 9% into 6/12 of a year, that is equal to 4500, at the end of each 10 semi-annual periods along with a single payment at the principal value of 1 lakh at the end of 10th period. The present value of this bond depends on the market interest rate, that is discount rate. At the time of computation, the discount rate was 8%. So, the present value of the bond compounded semi-annually can be given by this. This is the annuity 4,500 for 10 consecutive payments, and this is converted into the present value using a discounting method which is compounding semi-annually, and this is 1 lakh is converted into the present value using a discounting method which is compounded semi-annually. This comes out to be rupees 1,04,055.4, where I is the discount rate 8%, N is the maturity period which is 5 years, and M equal to 2, that is compounding twice per year. The present value of 36,499.03 of the annuity. Now, from where this 36,000 has come? If you see, this is the 36,499.03, and this comes from the annuity, payment of the annuity, the present value of this annuity, this group. So, the present value rupees 36,499.03 of the annuity 4,500 for 10 periods, so that if an investor invests rupees 36,499.03 on January 1, 2016, will in return will get 10 semi-annual payments of rupees 4,500 with first payment on 30th June 2016, when discount rate is 8%. The difference between the 10 semi-annual future payments of 4,500 is 4,50,000, and the present value of rupees 36499.03 equals to 8500.97. This return, that is 8500.97, the investor gets on an investment of rupees 36499.03 provides the investor an annual return of 8% compounded semi-annually. It is reasonable to accept that a bond promising to pay 9% coupon rate will sell for more value, that is rupees 104055.4, when the market is expecting to earn only 8%, that is discount rate. Thus, the 9% coupon bond value will pay 500 more semi-annually than the bond market is expecting. If a bond pays rupees 4,000 interest semi-annually for 10 periods and the principal is 1 lakh at the end of 10th period having a maturity of 5 years, the present value of the bond taking 8% discount rate is 1 lakh, that is rupees 4,500 minus rupees 4,000 is equal to 500. Now, the investor will be receiving an additional 500 semi-annually for 10 periods. If the investor is willing to pay rupees 4055.4 more than the bond's par value of rupees 1 lakh. The rupees 4055.4 more than the bond's par value amount is referred to as premium on bonds payable, bond premium, unamortized bond premium or premium. The present value of bond when compounded semi-annually is equal to 4,000, that is the annuity, and then we use the formula for semi-annual compounding plus 1 lakh is converted into the present value, comes out to be 1 lakh. What is a perpetual bond? A perpetual bond is a bond with no maturity date. Perpetual bonds are not redeemable, but pay a steady stream of interest forever. Some of the only notable perpetual bonds in existence are those that were issued by the British Treasury to pay off smaller issues used to finance the Napoleonic War in 1814. Some of the US believe it would be more efficient for the government to issue perpetual bonds which may help it avoid the refinancing cost associated with bond issues that have maturity dates. A perpetual bond is a bond that never matures. It has an infinite life. So, perpetual bonds present value P/B is equal to A I divided by 1 plus I to the power 1 plus A I divided by 1 plus I to the power 2, like this up to A I divided by 1 plus I to the power infinite. So, it is a summation of t equal to 0 to infinite A I 1 plus I to the power t. So, A I is the per period interest which the bond is paying and I is the discount rate. Now, we can divide the PBB by 1 plus I. So, it becomes A I 1 plus I whole square plus A I 1 plus I whole cube, so on so forth, plus A I 1 plus I to the power infinite. Now, if I deduct PB minus PB divided by 1 plus I, it is A I divided by 1 plus I to the power 1, or I can write down PBB is equal to A I divided by I, where A I is the annual interest, I is the annual discount rate, and the case of maturity period n is infinite. Example 11, valuation of perpetual bond. A bond P has a rupees 1000 par value having a annual coupon rate of 8%. If the discount rate is 10%, find the value of the perpetual bond. Solution: the annual interest is rupees 1000 into 0.08 is equal to 80 rupees. Discount rate is 10%, that is I is equal to 0.1. Hence, the present value of the perpetual bond is equal to rupees 80 divided by I is equal to rupees 800. Summary: what we have read in this lecture. Number 1, bond valuation with reference to basic bond valuation. Second, yield to maturity, and third, semi annual interest and bond value has been explained. Number 2, two methods for basic bond evaluation has been explained. Number 3, effect of time of maturity, coupon rate and discount rate on bond valuation has been explained. Number 4, premium and discount bonds and their dependency on discount rate have been explained. Number 5, perpetual bond and its present value has been explained. Thank you.